The next thing that we look at is testing and qualification. And testing and qualification is extremely important to the process as we're getting ready to do our chromatography. After we pack our column, and typically most of you folks, I would imagine, will be flow packing your column, we have to prepare the column and do an evaluation. So the evaluation is typically done by some test sample run through the column. And in the case of most aqueous resins, it normally takes the form of a high concentration marker of sodium chloride, or it can be acetone. So the column is set up on the test stand, and we would run through a test injection, and by using some sort of detection, we would monitor the efficiency of the flow of that test injection through the column. Typically, our test criteria, as you probably are aware, is asymmetry and plate count. So those are the values that we kind of live and die by as scientists in preparing the column. And we cannot stress highly enough that the values of the testing of the column should be within the accepted criteria that's set forth by the manufacturer of the resin. If those values are outside of the accepted criteria, and you try to run your chromatography after that, we really feel that your results are going to be in question, and more time should really be spent getting the column qualified within the column acceptable range considered by the resin manufacturer. So, in the slide, I've stated kind of garbage in, garbage out. So if you try to take a shortcut, it'll come back to haunt you. It's really the work needs to be put in on the front end. The resin slurry mix has to be correct. The flow rate has to be correct. The compression factor, if there is one in your resin, has to be correct. And your evaluation criteria has to be correct. Again, strongly suggest staying within the boundaries of what you've set for yourself and what the manufacturer has set for packing the column and getting it qualified. The next thing that I wanted to discuss is when we're in the lab, we may be working in isolation where we have only one purification to do within our group, and we're working kind of autonomously, and our result is our result. And we may be working on that similar size types of purifications over and over again. But again, we could be in a different situation where we're on a scale-up path. We're on a process development project. And we have to think about, where we're going with this purification. Oftentimes, the scientists will perform qualifications and purifications at a very low scale, and they're handing it off to another group. I believe it's incumbent upon the folks doing the smaller scale purification to have some respect and understanding of who's the next group that's going to get this and what are their challenges going to be. And before I select a specific column, have I talked to the column manufacturer and understood, do they have a product that is going to accommodate my scale-up team? Or is my scale-up team going to have to start all over again and use my SOP and adapt it to somebody else's larger hardware that may not be so scalable and give results that are not consistent with what's been handed up the ladder. So we feel it's very important that look at the big picture. The other thing, when we're selecting columns in a small lab, particularly a lab that has a low budget, this could be counterintuitive a little bit, but we oftentimes have customers coming to us, and our particular product line has a very high pressure tolerance. And they say, well, I can buy a cheaper column that has a lower pressure tolerance. That's of course true, but in a lab where there may be some considerations for budget, oftentimes in academia, we're going to finish that project and we're going to put that empty column in a drawer and someone else is going to need to use it. Well, that next experiment might call for a higher pressure tolerance column, and rather than going out and buying another one, we could reconfigure the frits on the column that we have and put it right into service for a higher pressure application. So we can always go up in pressure, but we can't always go down in pressure. So I think that's something particularly for smaller labs, that you can develop a familiarity with a column family of products. And I think that familiarity makes the job easier when you go to set the column up. What are the challenges to packing the column, mounting a packing adapter, configuring the column, how it runs, how to mount frits. I think just selecting a column that has a higher initial pressure tolerance than you might even need indicates that the column is built with more robustness and will be more durable over the long run, but also has more flexibility in the lab. So again, just be sensitive to your colleagues in scale up or in the lab, maybe that might need that column for something else later on.